Prashant. Today I am going to start with 9th standard chapter 2, that is numericals of 2C, that is motion in one dimension, numericals of part C. Right? In my channel you will find various topics in physics like standard 10, 9th, general topics also. I am coming with some 11th standard topics which are related to 11th standard but based on your standard 9th and 10th. Right? They are very important topics that I am going to discuss. But after completion of my all 9th standard and 10th standard topics, right? Just come to this part. This is numericals of chapter. It is 2C numericals. I am following Selena. I am following Selena. That is edition is 2022. Edition is 2022. This is the edition. Okay. In this first numerical is given as a body start from rest. So whenever they say rest, means initial velocity is equal to 0. With a uniform acceleration, now A is given as 2 meter per second square. This is the acceleration. Find the distance covered by the body. That means they want S, and time is given as 2 seconds. Time is given as 2 seconds. So I can use this equation, that is second kinematical equation, S is equal to, it is ut plus half at square. Now this comes out to be u is 0 plus this is half, a ka value is 2, t is 2, the whole square. This 2 and 2 cancel, so this comes out to be 4 meter, and the distance covered in 2 seconds. Right? This is the first question. We come to the next question, that is second. What is given? A body start with an initial velocity. With an initial velocity, the u is given as 10 meter per second. And acceleration, that is a is given as 5 meter per second square. Time is given as 5 seconds. And what they want is distance covered. Right? So I can write here, since we have S is equal to ut plus half at square. Now here I am substituting that part. S is equal to u is 10, t is equal to 5 plus half, a is 5 into t is 5 the whole square. Now if you substitute this part, this comes out to be 11.112.5 meter. Right? This is about the second meter. Right? Check the third one. We go with third one. It's given in third. In third numerical, a vehicle is accelerating on a straight road. Its velocity at any instant is given. I'm calling this as, say it is v1. It is 30 kilometer per hour. So you have to convert into 5 by 18 meter per second. I will convert that kilometer per hour to meter per second. Then after 2 seconds, that is t1 is equal to 2 seconds. Its velocity v2 becomes 33.6 into 5 by 18 meter per second. Again after 2 seconds, the t2 is equal to 2 seconds. V3 comes out to be, it is 37.2 into 5 by 18 meter per second. What they want, acceleration in each part, right? A1 is question mark, A2 is question mark. I can write here, since A1 is V2 minus V1 upon T1. We substitute the value, V2 37.2 minus 30, common, it is 5 by 18 into, this is 2. If you solve this comes up to be 0.5 meter per second square. Similarly, you can go with A2, V3 minus V2 upon T2. V3 is how much? Sorry, this comes up to be 33.6 minus 30 into 5 by 18. And here it is 37.2 minus 33.6 it is 5 by 18 upon this is 2, right? If you solve this, again this comes up to be 0.5 meter per second square. Now since your A1 is equal to A2, therefore this body is moving with uniform acceleration. It is moving with what? Uniform acceleration, right? This is the one. Check the fourth one. What is given in fourth? A body is initially at rest, means u is equal to 0. Starting with a constant acceleration, a is given as 2 meter per second square. Calculate the velocity acquired and the distance travelled in 5 seconds. Velocity and distance travelled after t is equal to 5 seconds. So we have, since v is equal to u plus 80, 0 plus 2 into 5, which is 10 meter per second, and since s is equal to ut plus half at square, this is 0 plus half, a is 2, ut is 5 square. This comes out to be 25 meter. This is the fifth one. Check the fifth question. In fifth, a bullet is initially moving with a velocity of, that is u is given as 20 meter per second. Strike a target and come to rest after penetrating a distance of, the s is given as 10 centimeter, which is 0.1 meter. Because this is divided by 100, that comes out to be meter, that is 0.1 meter. Okay, then come to rest, the final velocity is equal to 0. Calculate the retardation produced. The A is question. Now here time is not given, but S, V and U is given. So I can use this equation, third equation, V square is equal to U square plus 2AS. This is 0, this is 20, the whole square, plus 2 into A into S is 0.1. So if I solve this, this comes up to be, this is equal to, it is minus 0.2 A is equal to, this is 400, right, which is A equal to 4000 divided by 2 with the minus sign, that comes out to be minus 2000 meter per second square. Now here negative sign shows retardation. Negative sign shows what? Retardation. So I can write here therefore retardation is equal to, it is 2000 meter per second square. Retardation is equal to 2000 meter per second square. Right? That is about the fifth. Check the next one. Right? Now sixth one. A train is moving with a velocity of 20 meter per second. That is u is given. That is 20 meter per second. It is brought to rest, matlab v equal to 0, by applying brakes in time is equal to 5 seconds. Calculate the retardation. A पूछा. So I can write A is equal to, it is v minus u upon t. V is 0 minus 20 upon 5 minus 4 meter per second square. So write your negative sign shows retardation. It is called as what? Retardation. So I can write here therefore retardation is equal to, it is 4 meter per second square. Retardation is equal to 4 meter per second square. Right? Abhi check the seventh one. Seventh is very important. A train travels with a speed of 60 km per hour from station A to B and then come back with the speed of 80 km per hour from B to A. Find the average speed and the average velocity. So right here, this is your station A and this is your station B. Right? Let the distance between these two stations 8D. Right? So V1 is given as kitna? It is 60 km per hour. V2 is given as 80 km per hour. V1, V2, they are given. Right? So right here, let D be the distance between two stations. It is D be the distance between two stations. So I can write here therefore V is equal to V1 is D upon T1. So I can write T1 is D upon D1, which is D upon 60 hours. This is the time. Similarly, since V2 is D upon T2, so I can write T2 is equal to D upon V2, which is D upon 80 hours. This is D upon 80 hours. Now can I write therefore, we write here therefore, average speed is equal to, it is total distance upon total time. Total distance is D plus D upon T1 plus T2, right? So if you solve this, this comes out to be average speed is equal to, it is 2D upon D upon 60 plus D upon 80. So this comes out to be, this is 2D upon 80D plus 60D upon 60 into 80. Right? If you take this up, this comes out to be 2D into 60 into 80 upon 140D. DD cancel. This 0 is cancelled. This 1s are 7s are. If you solve this, this comes out to be 68.57. It is kilometer per hour. This is kilometer per hour. Kilometer per hour. Right? Now, what is the next part they have asked? Next part they have asked, what is the average velocity? Since we have average velocity is equal to, it is total displacement upon total time. But total displacement is 0 because body is, the train is again coming back to the station A. So displacement will be 0 upon time, whatever. So average velocity will be 0. Average velocity will be what? 0. Right? This is about the 7th. Check the 8th. What is given in 8th? In 8th question, a train is moving with a velocity of 90 km per hour. That is the initial velocity is 90 km per hour. Now you have to convert this into meter per second. Right? This you have to convert this into meter per second. So this is 90 into 5 by 18, which is 25 meter per second. This is initial velocity. It is stopped by applying a brakes. It is V is equal to 0, right? By producing a retardation. A is given as minus 0.5 meter per second square. Right? Find the velocity after 10 seconds. That is V1 is question mark, T1 is equal to 10 seconds. And what is the time taken by the train to come to rest? The V2 is 0. So T2 is equal to question mark. How much time लगेगा to body come to rest, right? This is very important. Since we have V is equal to U plus 80, so I'm writing V1. This is U 81. U is 25. A is minus 0.5 into time is 10. This is 25 minus 5, which is 20 meter per second, right? Now in next part, this how much time will it take to come to rest? Since we have v is equal to u plus 80, this is your 0, right? U is your 25, a is minus 0.5, and time is t2. So I am writing this is equal to 25 minus 25 is equal to, this is 1 by 2 into t2. So I will take this to other side. This is t2 is equal to 50 seconds. So the time taken by that body to come to rest will take what? It will take 50 seconds to come to rest. Right? This is about the 8. Now check the next one, that is 9. And what is given in 9? In 9th question, a car travels a distance of 100 meters with a constant acceleration and average velocity. Here, your displacement is 100 meters, and here your average velocity is equal to 20 meters per second. Final velocity acquired, that is v, is given as 25 meters per second. They want initial velocity and the acceleration of car, right? So we know that average velocity is equal to, it is u plus v upon 2. Now here this is given as 20, this is u plus v is 25 upon 2. So if you solve this, this comes out to be 40 is equal to u plus 25. So this u comes out to be 15 meters per second. This is the initial velocity with which body is moving. Now what is acceleration? So since we have v square is equal to u square plus 2as, this is v square is given, that is 25 the whole square is equal to u is 15 the whole square plus 2 into e. Now displacement is given as 100, right? So if you solve this, this comes up to be, this is equal to 625 minus 225, right, upon this is 2 into 100, that comes up to your a. This a comes up to be 2 meters per second square. This is your acceleration, right? Now to go with the next sum, that is question number 10. Now total 15 numericals. So out of that, now the lengthy numericals will start. Check the 10th. When a brakes are applied to a bus, retardation produced is, now just underline the retardation given, that is minus. A is given as minus, it is 25 centimeter per second square. Now this is centimeter, you have to convert this into SI. This is minus 25 by 100, which is minus 1 by 4 meter per second square. This is your acceleration, right? Then it takes 20 seconds to stop. Now t is given as 20 seconds, t is equal to 0. Find the initial velocity and distance traveled. Method u is question mark and s given. So I can write here, since v is equal to u plus 80. So 0 is equal to, this is u plus a is what, minus 1 by 4 into t is what. So I can write this is equal to, this is equal to, u is equal to 20 by 4, which is 5 meters per second. This is what initial velocity. Then what is the distance travelled? So s is equal to, getting ut plus half 80 square. U kitna? It is 5 into 2 is 20 plus half, a is minus 1 by 4 into t is 20 the whole square. Right? If you substitute this value, this comes out to be 50 meters. Distance covered will be what? 50 meters. Right? This is the answer. Right? This is your 50 meters. Okay. Now we will go with 11th. What is given in 11th? Now in 11th sum, a body moves from rest. Underline the word from rest. So your u is equal to 0. It travels a distance of, yes, with the uniform acceleration and travels a distance of, s is given as 270 meters in time 3 seconds. Now the 3 seconds. Find the velocity of car after 10 seconds. T1, we are 10 seconds, velocity V1 to. First, we need to find acceleration. So, can I use this part as S is equal to ut plus half at square. So, this is 270 is equal to 0 plus half, right? A is unknown, E is 3 the whole square, right? So, this comes out to be, this is 270 into 2 upon 9 is equal to 8. This is 9 ones are 9, 3s are. This A comes out to be 60 meter per second square. Now what they want here after that, they want what is the velocity after 10 seconds. We can write here V1 is U plus A T1. This is 0 plus, this is 60 into T1 is 10. This is V1 is equal to 600 meter per second. So this is the velocity with which this body is moving after 10 seconds, right? Now 4 more numericals, that is 12, 13, 14 and 15. Now the 12th one is very important and little lengthy. This is a frequently asked question because it's a different type. Check what is given. A body is moving with a constant acceleration, travels a distance of 3 distances 3 meter and 8 meter. So here your S1 is given as 3 meter, S2 is given as 8 meter. In time 1 second and 2 seconds means T1 is equal to 1 second, T2 is equal to 2 seconds. What they want here, A acceleration and initial velocity U. So I am using this part as since S is equal to ut plus half at square. What I have written, S is equal to ut plus half at square. Now first case में I am writing S1 ut1 half a t1 square. So S1 कितना है हमारा 3. This is u into t1 is 1 plus half a t1 मतलब 1 the whole square. So this comes out to be 3 is equal to u plus a upon 2. So can I write here u is equal to 3 minus a upon 2. This is equation number 1. U is equal to 3 minus a upon 2. That is equation number 1. What about second equation? Second equation is what? Since S2 is equal to u t2 plus half a t2 square. So this comes out to be 8 is equal to u into 2 plus half a into 2 the whole square. Right? If I cancel this 2 with this square, so this comes out to be 4 is equal to, again divided by 2 everywhere. It is u plus a. Right? So I can write this part, therefore this is u, I can write here therefore u is equal to, it is 4 minus a. U is equal to 4 minus a. This is equation number 2. I can substitute this equation, substitute equation 2 in what manner? Or you can say equate this part. So I can write this is equal to, this is 4 minus a is equal to 3 minus a upon 2. So just multiply here, this comes out to be, it is 4 minus a bracket के बाहर 2 is equal to, this is 6 minus a upon that 2, तो 2 मैंने इधर ले लिया. So this comes out to be 8 minus 2a is equal to 6 minus a. This comes out to be 8 is equal to 6 minus a plus 2a. Right? So this comes out to be, this is a is equal to 2 meter per second square. This is the acceleration. Now what you will do, I will substitute this value of a, substitute a and say equation 2. So what will get? This is u is equal to, this is 4 minus 2 which is 2 meter per second. So initial velocity will be 2 meter per second and initial acceleration, acceleration is also equal to 2 meter per second square. Right? This is about the 12th. Now check the 13th one. What is given in 13th? In 13th question, a car travels with a uniform velocity of 25 meter per second for 5 seconds. Means u is given as 25 meter per second for time t is equal to 5 seconds. The brakes are then applied. So I will write this is T1. The brakes are then applied to the car uniformly retarded and come to rest with the V equal to 0. In time T2 is 10 seconds, further 10 seconds. Okay. Find the distance with which the car traveled before the brakes are applied. So we have U is equal to S upon T1. So I can write here S is equal to U into T1. U is 25, T1 is 5, that is 125 meter. So the distance covered before you apply the brake. Then second part में find the retardation produced. एक तो retardation के लिए क्या होगा, since we have V is equal to U plus AT. यहाँ पे V is 0, U plus A into T2. This is 0. U is 25 plus A. T2 is 10. So I can write here A is equal to minus 25 by 10, which is A is minus 2.5 meter per second square. This is the acceleration. So I will write here negative sign shows retardation. Negative sign shows retardation. Therefore, I can write here retardation is equal to 2.5 meter per second square. Now next part, what they want, find the retardation, distance traveled by a car applying the brake. So we can write here S is equal to UP plus half AT square. So this is distance covered applying brake. After this is S2. This is U into T2 plus half A into T2 square. Right? So this comes out to be 25 into 10 minus half because A is negative. Into this is 2.5 into E will be how much? It is 10, the whole square, right? If you solve this, this comes out to be again 125 meter. This comes out to be 125 meter, right? So this is about the 13th. Now two more numericals. I just said. What is the next question? A spacecraft is flying in a straight course with a velocity of, so I am calling initial velocity 75 kilometer per second. If as it is, fires the rocket motor for T1 is equal to 6 seconds. In the time T1 is equal to 6 seconds. At the end of this time, speed of this rocket is 120 kilometer per second in the same direction. Find the average acceleration. They want A is question mark. And the distance traveled by spacecraft in the first 10 seconds after the rocket motor was started. So capital T is given as T second, 10 seconds. But what they are saying, this is T1 is equal to 6 seconds because motor was started only for 6 seconds. So after that it is moving. So I can write here, since capital T is equal to, it is T1 plus T2. So I can write here T2 is equal to capital T minus T1, which is 10 minus 6, which is equal to 4 seconds. So this rocket is moving with velocity of 120 km per second for 4 seconds. This rocket is moving with velocity of 120 km per second for 4 seconds. Now what they want here, first they want acceleration. The acceleration is very easy. A is equal to V minus U upon T. V is 120 minus 75 upon 6. That comes out to be 7.5 kilometer per second square. Keep as it is, right? Now what they want, distance covered in 10 seconds. So since I can write here total distance covered S is equal to S1 plus S2. Now S1 is the distance covered in 6 seconds, and S2 is the distance covered in 4 seconds. Here it is accelerated. This distance covered is what? Accelerated motion, because there is acceleration. and here it is moving with a uniform velocity. So I can write here therefore s is equal to u t1 plus half a t1 square. This is your s1 plus s2 is v into t2, right? Now here u is 0, so this is not 0, this is 75 into t1 is how much? 6 plus half a is how much? 7.5 into t1 kitna है? 6 the whole square plus this is v is 120 into 4. If you solve this entire part, this comes out to be total distance covered is 1065 kilometer. Total distance covered will be 1065 kilometer, right? This is about the 14th. And last thing is again important. What is given in last? A train start from rest, accelerate uniformly at the rate of 2 meters per second. I will draw graph for this one, right? I will just draw graph for this one. A train start from rest. So here train is starting from rest and the v equal to 0. It accelerates uniformly at the rate of 2 meters per second square. This is your acceleration 2 meters per second square. Then for 10 seconds, this is t is equal to how much? 10 seconds. After that, it maintains a constant speed for 200 seconds. So your uniform speed, right, for t2 200 seconds, right? So यहाँ पे acceleration a2 will be 0. Then brakes are then applied and the train uniformly retarded come to rest in 50 seconds. So it come to rest again. So इधर initial velocity हो जाएगा, that is इसका final velocity कितना रहेगा? So whatever value that is moving with इसका final velocity, that is something meter per second. Now here it come to rest, मतलब इसका final velocity कितना होगा? 0. So इसका जो initial velocity है is same as final velocity of this body, right? So your final velocity 0 and time t2 is equal to how much? T3 is equal to next 50 seconds, last 50 seconds. Now what they want here, find the maximum velocity reached, acceleration produced, then in last 15 seconds there is retardation, and total distance covered and average velocity of car, right? So check the first part. The first part may find the what? Find the maximum velocity reached. So since we write here v is equal to u plus a t, right? This is the formula. So this is u is equal to 0 plus a1 into t1. a1 is 2, t1 is 10, that comes to be 20 meter per second. So this body is moving with the 20 meter per second for next 200 seconds, right? And after that it is come to rest with a retardation. We have to find the retardation. The T3 is question. So I can write here second part के since your train is moving with कितना? It is 20 meter per second for 200 seconds. Therefore, initial velocity for retardation is 20 meter per second, right? And then final velocity v is equal to 0. So I can write here, therefore v is equal to u plus a into t. This is 0, u is 20 plus a3 into what t3. So I can write here, therefore your a3 is equal to 20 minus 20 upon 50 minus 4 meter per second square minus it is 0.4 meter per second square, right? So I will write here therefore or negative sign shows retardation. Negative sign shows retardation. So I can write therefore retardation is equal to 0.4 meter per second square. This we got second one. Now what they want here, find the total distance traveled. Total distance traveled. So we write here therefore total distance traveled is equal. It is S is equal to S1 plus S2 plus S3. So what is S1 distance traveled in first 10 seconds? S2 is distance traveled in 200 seconds and S3 is the distance traveled in last 50 seconds. So I can write here therefore S is equal to, this is first part में U T1 plus half A1 T1 square. This is first part. Second part में S2 is V into T2 plus third part में again it is accelerated, that is U into T3 plus half A3 T3 square. Right? This is 0, so I am writing this is 0 plus half A1 is 2 into P1 is 10 the whole square plus this comes up to be V is 20 into 200 plus this is U matlab 20 into 50 minus half into 0.4 into 50 the whole square. Right? If you substitute the entire part, this comes up to be, it is 4600 meter. The distance covered is 4600 meter. Now last part में what they want, average velocity. Average velocity means average velocity is equal to, it is total distance upon total time. Total distance upon total time. So total distance is equal to S upon P. S is equal to 4600 upon total time will be, it is 10 plus 200 plus 50. That comes out to be 4600 upon 260. Right? So if you solve this, this comes out to be something meter per second. Right? That comes out to be 17.69. This is 17.69 meter per second. This is the average velocity. Right? That's it for this video, friends. Just please do subscribe my channel, and if you like this content, please do share this with your friends. Thank you.